Let's synthesize step by step iterative dataset synthesis with large language models by extrapolating errors from small models. Data synthesis is a promising way to train a small model with very little labeled data. One approach for data synthesis is to leverage the rich knowledge from large language models to synthesize pseudo-training examples for small models, making it possible to achieve both data and compute efficiency at the same time. However, a key challenge in data synthesis is that the synthesized dataset often suffers from a large distributional discrepancy from the real task data distribution. Thus, in this paper, we propose synthesis step by step, S3, a data synthesis framework that shrinks this distribution gap by iteratively extrapolating the errors made by a small model trained on the synthesized dataset on a small real-world validation dataset using a large language model. Extensive experiments on multiple NLP tasks show that our approach improves the performance of a small model by reducing the gap between the synthetic dataset and the real data, resulting in significant improvement compared to several baselines, 9.48% improvement compared to 0gen and 2.73% improvement compared to GoldGen, and at most 15.17% improvement compared to the small model trained on human annotated data. Teaching language models to self-improve through interactive demonstrations. The self-improving ability of large language models, LLMs, enabled by prompting them to analyze and revise their own outputs, has garnered significant interest in recent research. However, this ability has been shown to be absent and difficult to learn for smaller models, thus widening the performance gap between state-of-the-art LLMs and more cost-effective and faster ones. To reduce this gap, we introduced Tripost, a training algorithm that endows smaller models with such self-improvement ability, and show that our approach can improve a Llama 7B's performance on math and reasoning tasks by up to 7.13%. In contrast to prior work, we achieve this by using the smaller model to interact with LLMs to collect feedback and improvements on its own generations. We then replay this experience to train the small model. Our experiments on 4 math and reasoning datasets show that the interactive experience of learning from and correcting its own mistakes is crucial for small models to improve their performance. The SALMONN, towards generic hearing abilities for large language models. Hearing is arguably an essential ability of artificial intelligence, AI, agents in the physical world, which refers to the perception and understanding of general auditory information consisting of at least 3 types of sounds: speech, audio events, and music. In this paper, we propose SALMONN, a speech-audio-language-music open neural network, built by integrating a pre-trained text-based large language model, LLM, with speech and audio encoders into a single multimodal model. SALMONN enables the LLM to directly process and understand general audio inputs and achieve competitive performances on a number of speech and audio tasks used in training, such as automatic speech recognition and translation, auditory information-based question answering, emotion recognition, speaker verification, and music and audio captioning, etc. SALMONN also has a diverse set of emergent abilities unseen in the training, which includes but is not limited to speech translation to untrained languages, speech-based slot filling, spoken query-based question answering, audio-based storytelling, and speech-audio co-reasoning, etc. The presence of the cross-modal emergent abilities is studied, and a novel few-shot activation tuning approach is proposed to activate such abilities of SALMONN. To our knowledge, SALMONN is the first model of its type and can be regarded as a step towards AI with generic hearing abilities. An interactive demo of SALMONN is available at project's website, and the training code and model checkpoints will be released upon acceptance. DreamSpace, dreaming your room space with text-driven panoramic texture propagation. Diffusion-based methods have achieved prominent success in generating 2D media, however accomplishing similar proficiencies for scene-level mesh texturing in 3D spatial applications, for example XR/VR, remains constrained, primarily due to the intricate nature of 3D geometry and the necessity for immersive free viewpoint rendering. In this paper, we propose a novel indoor scene texturing framework, which delivers text-driven texture generation with enchanting details and authentic spatial coherence. The key insight is to first imagine a stylized 360-degree panoramic texture from the central viewpoint of the scene, and then propagate it to the rest areas with inpainting and imitating techniques. To ensure meaningful and aligned textures to the scene, we develop a novel, coarse-to-fine panoramic texture generation approach with dual texture alignment, which both considers the geometry and texture cues of the captured scenes. To survive from cluttered geometries during texture propagation, we design a separated strategy, which conducts texture inpainting in confidential regions, and then learns an implicit imitating network to synthesize textures in occluded and tiny structural areas. Extensive experiments and the immersive VR application on real-world indoor scenes demonstrate the high quality of the generated textures and the engaging experience on VR headsets. Project webpage, project's website. Democratizing reasoning ability. Tailored learning from large language model. Large language models, LLMs, exhibit impressive emergent abilities in natural language processing, but their democratization is hindered due to huge computation requirements and closed-source nature. Recent research on advancing open-source smaller LMs by distilling knowledge from black box LLMs has obtained promising results in the instruction-following ability. However, the reasoning ability, which is more challenging to foster, is relatively rarely explored. In this paper, we propose a tailored learning approach to distill such reasoning ability to smaller LMs to facilitate the democratization of the exclusive reasoning ability. In contrast to merely employing LLM as a data annotator, we exploit the potential of LLM as a reasoning teacher by building an interactive multi-round learning paradigm. This paradigm enables the student to expose its deficiencies to the black box teacher, who then can provide customized training data in return. Further, to exploit the reasoning potential of the smaller LM, we propose self-reflection learning to motivate the student to learn from self-made mistakes. The learning from self-reflection and LLM are all tailored to the student's learning status, thanks to the seamless integration with the multi-round learning paradigm. Comprehensive experiments and analysis on mathematical and common-sense reasoning tasks demonstrate the effectiveness of our method. The code will be available at project's website. DPM Solver v3, Improved Diffusion OD, Solver with Empirical Model Statistics. Diffusion Probabilistic Models, DPMs, have exhibited excellent performance for high-fidelity image generation, while suffering from inefficient sampling. Recent works accelerate the sampling procedure by proposing fast ODE solvers that leverage the specific OD form of DPMs. However, they highly rely on specific parameterization during inference, such as noise data prediction, which might not be the optimal choice. In this work, we propose a novel formulation towards the optimal parameterization during sampling that minimizes the first-order discretization error of the ODE solution. Based on such formulation, we propose DPM Solver v3, a new fast ODE solver for DPMs, by introducing several coefficients efficiently computed on the pre-trained model, which we call empirical model statistics. We further incorporate multi-step methods and a predictor-corrector framework, and propose some techniques for improving sample quality at small numbers of function evaluations, NFE, or large guidance scales. Experiments show that DPM Solver v3 achieves consistently better or comparable performance in both unconditional and conditional sampling, with both pixel space and latent space DPMs, especially in 5 to 10 NFEs. We achieve FIDs of 12.21, 5 NFE, 2.51, 10 NFE on unconditional CIFAR 10, and MSE of 0.55, 5 NFE 7.5 guidance scale on stable diffusion, bringing a speed up of 15% to 30% compared to previous state-of-the-art training-free methods. Code is available at the project's website. Contrastive Prefence Learning, learning from human feedback without RL. Reinforcement learning from human feedback, RLHF, has emerged as a popular paradigm for aligning models with human intent. Typically, RLHF algorithms operate in two phases. First, use human preferences to learn a reward function, and second, align the model by optimizing the learned reward via reinforcement learning, RL. This paradigm assumes that human preferences are distributed according to reward, but recent work suggests that they instead follow the regret under the user's optimal policy. Thus, learning a reward function from feedback is not only based on a flawed assumption of human preference, but also leads to unwieldy optimization challenges that stem from policy gradients or bootstrapping in the RL phase. Because of these optimization challenges, contemporary RLHF methods restrict themselves to contextual bandit settings, for example, as in large language models, or limit observation dimensionality, for example, state-based robotics. We overcome these limitations by introducing a new family of algorithms for optimizing behavior from human feedback, using the regret-based model of human preferences. Using the principle of maximum entropy, we derive Contrastive Prefence Learning, CPL, an algorithm for learning optimal policies from preferences without learning reward functions, circumventing the need for RL. CPL is fully off-policy, uses only a simple contrastive objective, and can be applied to arbitrary MDPs. This enables CPL to elegantly scale to high-dimensional and sequential RLHF problems, while being simpler than prior methods. Tuna. Instruction tuning using feedback from large language models. Instruction tuning of open-source large language models, LLMs like LLaMA, using direct outputs from more powerful LLMs such as InstructGPT and GPT-4, has proven to be a cost-effective way to align model behaviors with human preferences. However, the instruction-tuned model has only seen one response per instruction, lacking the knowledge of potentially better responses. In this paper, we propose fine-tuning an instruction-tuned LLM using our novel probabilistic ranking and contextual ranking approaches to increase the likelihood of generating better responses. Probabilistic ranking enables the instruction-tuned model to inherit the relative rankings of high-quality and low-quality responses from the teacher LLM. On the other hand, learning with contextual ranking allows the model to refine its own response distribution, using the contextual understanding ability of stronger LLMs. Furthermore, we apply probabilistic ranking and contextual ranking sequentially to the instruction-tuned LLM. The resulting model, which we call Tuna, consistently improves the performance on supernatural instructions, 119 test tasks, elementary, 25 test tasks, Vicuna QA, and can even obtain better results than several strong reinforcement learning baselines. Our code and data are available at the project's website. Auto-Instruct, automatic instruction generation, and ranking for black box language models. Large language models, LLMs, can perform a wide range of tasks by following natural language instructions without the necessity of task-specific fine-tuning. Unfortunately, the performance of LLMs is greatly influenced by the quality of these instructions, and manually writing effective instructions for each task is a laborious and subjective process. In this paper, we introduce Auto-Instruct, a novel method to automatically improve the quality of instructions provided to LLMs. Our method leverages the inherent generative ability of LLMs to produce diverse candidate instructions for a given task, and then ranks them using a scoring model trained on a variety of 575 existing natural language processing, NLP, tasks. In experiments on 118 out-of-domain tasks, Auto-Instruct surpasses both human-written instructions and existing baselines of LLM-generated instructions. Furthermore, our method exhibits notable generalizability even with other LLMs that are not incorporated into its training process. Creative robot tool use with large language models. Tool use is a hallmark of advanced intelligence, exemplified in both animal behavior and robotic capabilities. This paper investigates the feasibility of imbuing robots with the ability to creatively use tools in tasks that involve implicit physical constraints and long-term planning. Leveraging large language models, LLMs. We develop RoboTool, a system that accepts natural language instructions and outputs executable code for controlling robots in both simulated and real-world environments. RoboTool incorporates 4 pivotal components: an analyzer that interprets natural language to discern key task-related concepts; 2, a planner that generates comprehensive strategies based on the language input and key concepts; 3, a calculator that computes parameters for each skill; and IV, a coder that translates these plans into executable Python code. Our results show that RoboTool can not only comprehend explicit or implicit physical constraints and environmental factors, but also demonstrate creative tool use. Unlike traditional task and motion planning TAMP methods that rely on explicit optimization, our LLM-based system offers a more flexible, efficient, and user-friendly solution for complex robotics tasks. Through extensive experiments, we validate that RoboTool is proficient in handling tasks that would otherwise be infeasible without the creative use of tools, thereby expanding the capabilities of robotic systems. Demos are available on our project's website. H2O, Open Ecosystem for State-of-the-Art Large Language Models. Large language models, or LLMs, have revolutionized AI. However, they also present several risks, including biased, private, copyrighted, or harmful text. To address these concerns, we propose an open, transparent, and safe solution. We have developed a comprehensive open-source ecosystem for creating and testing LLMs. The main objective of this project is to promote open alternatives to closed-source approaches. We have released H2O-GPT, a collection of fine-tuned LLMs ranging from 7 to 70 billion parameters. Additionally, we introduce H2O LLM Studio, a framework and graphical user interface that enables efficient fine-tuning, evaluation, and deployment of LLMs using the most recent state-of-the-art techniques. Our code and models are licensed under the permissive Apache 2.0 licenses. We believe that open-source language models contribute to the advancement of AI by making it more accessible and trustworthy. The demo can be found on the project's website. ToolChain *, efficient action space navigation in large language models with A** search. Large language models, LLMs, have demonstrated powerful decision-making and planning capabilities in solving complicated real-world problems. LLM-based autonomous agents can interact with diverse tools, for example, functional APIs, and generate solution plans that execute a series of API function calls in a step-by-step manner. The multitude of candidate API function calls significantly expands the action space, amplifying the critical need for efficient action space navigation. However, existing methods either struggle with unidirectional exploration in expansive action spaces, trapped into a locally optimal solution, or suffer from exhaustively traversing all potential actions, causing inefficient navigation. To address these issues, we propose ToolChain *, an efficient tree search-based planning algorithm for LLM-based agents. It formulates the entire action space as a decision tree, where each node represents a possible API function call involved in a solution plan. By incorporating the A* search algorithm with task-specific cost function design, it efficiently prunes high-cost branches that may involve incorrect actions, identifying the most low-cost valid path as the solution. Extensive experiments on multiple tool use and reasoning tasks demonstrate that ToolChain * efficiently balances exploration and exploitation within an expansive action space. It outperforms state-of-the-art baselines on planning and reasoning tasks by 3.1% and 3.5% on average, while requiring 7.35 times and 2.31 times less time, respectively. ScaleLong, towards more stable training of diffusion model via scaling network long skip connection. In diffusion models, UNet is the most popular network backbone since its long skip connects LSCs. To connect distant network blocks can aggregate long-distant information and alleviate vanishing gradient. Unfortunately, UNet often suffers from unstable training in diffusion models, which can be alleviated by scaling its LSC coefficients smaller. However, theoretical understandings of the instability of UNet in diffusion models and also the performance improvement of LSC scaling remain absent yet. To solve this issue, we theoretically show that the coefficients of LSCs in UNet have big effects on the stableness of the forward and backward propagation and robustness of UNet. Specifically, the hidden feature and gradient of UNet at any layer can oscillate, and their oscillation ranges are actually large, which explains the instability of UNet training. Moreover, UNet is also provably sensitive to perturbed input and predicts an output distant from the desired output, yielding oscillatory loss and thus oscillatory gradient. Besides, we also observe the theoretical benefits of the LSC coefficient scaling of UNet in the stableness of hidden features and gradient, and also robustness. Finally, inspired by our theory, we propose an effective coefficient scaling framework, ScaleLong, that scales the coefficients of LSC in UNet and better improves the training stability of UNet. Experimental results on 4 famous datasets show that our methods are superior to stabilized training and yield about 1.5x training acceleration on different diffusion models with UNet or UVIT backbones. Code, project's website. SILC, improving vision language pretraining with self-distillation. Image-text pretraining on web-scale image caption dataset has become the default recipe for open vocabulary classification and retrieval models, thanks to the success of CLIP and its variants. Several works have also used CLIP features for dense prediction tasks and have shown the emergence of open-set abilities. However, the contrastive objective only focuses on image-text alignment and does not incentivize image feature learning for dense prediction tasks. In this work, we propose the simple addition of local-to-global correspondence learning by self-distillation as an additional objective for contrastive pre-training to propose SILC. We show that distilling local image features from an exponential moving average (EMA) teacher model significantly improves model performance on several computer vision tasks, including classification, retrieval, and especially segmentation. We further show that SILC scales better with the same training duration compared to the baselines. Our model SILC sets a new state-of-the-art for zero-shot classification, few-shot classification, image and text retrieval, zero-shot segmentation, and open vocabulary segmentation. Towards understanding sycophancy in language models, reinforcement learning from human feedback, RLHF, is a popular technique for training high-quality AI assistants. However, RLHF may also encourage model responses that match user beliefs over truthful responses, a behavior known as sycophancy. We investigate the prevalence of sycophancy in RLHF-trained models and whether human preference judgments are responsible. We first demonstrate that 5 state-of-the-art AI assistants consistently exhibit sycophantic behavior across 4 varied free-form text generation tasks. To understand if human preferences drive this broadly observed behavior of RLHF models, we analyze existing human preference data. We find that when a response matches a user's views, it is more likely to be preferred. Moreover, both humans and preference models, PMs, prefer convincingly written sycophantic responses over correct ones, a negligible fraction of the time. Optimizing model outputs against PMs also sometimes sacrifices truthfulness in favor of sycophancy. Overall, our results indicate that sycophancy is a general behavior of RLHF models, likely driven in part by human preference judgments favoring sycophantic responses.